So today we're doing 5.7, reflections and symmetry. The goal today is to identify and use reflections and use lines of symmetry. So a reflection is a transformation that creates. So it's a transformation that creates a mirror image.
Why are you looking at me?
Okay, so that's the mirror image. You guys have seen this looking into a mirror. You know what a reflection is. After that, we have a line of symmetry. It's the line the line the original figure is reflected over. Okay, so those are two definitions today. And then we have some properties. So the reflected image is, and the blank is going to be congruent to the original figure. What does it mean to be congruent? Yep, same measure, equal. So the first blank is congruent. The second one says the orientation of the reflected image is, and then it's going to be reversed. So orientation means direction. So that means the direction will be reversed. And then third, the line of reflection is the perpendicular bisector of the segments joining the corresponding points. So perpendicular bisector. So what does it mean to be perpendicular? Yep, makes a 90-degree angle, right angle. Bisector means to split in half. Yep. So it's going to bisector just means it's going to bisect into two congruent parts. So our follow-up question is what I'm going to scroll up to. Is anybody still writing this page? Okay, I'm going to give you a second because I still. So the first one says draw the reflections over line K. So a reflection here is going to be as if this was the mirror. And so for it to be reflected, we're just going to copy it in the reverse way. So here we have our first E. I did it because that's just what it looked like on this one, so that's why. Our next one up, we have the E over K. So now we have and then our last one, which is always the hardest for me to draw, is now we are doing it across, so it's going to be below. Okay.
I did it the other way. Why do you gotta do it that way?
And so it says to tell whether the gray figure is a reflection of the black figure. They both look black here because they've been copied so many times. So we're going to go with the top one's the original, the bottom one is the reflected. So we want to see, is the image congruent to the original figure? So in the first one, is it the same size? Yes. So our first blank is yes. Did the orientation of the image reverse? So are they going in different directions now? It is, right? So you see that the point up here, yep, is pointing up, and then down here, the point's pointing down. So it is a different direction. And then our last one is when we connect the corresponding points, are they going to be perpendicular to M? So if I connect here, here, and here, does that form perpendicular lines? It does, yep. So we have yes there. So since we answered yes to all of them, we know that this is a reflection. And so we can say yes because all properties are met. So in the blank is all properties are met. Okay, our next one up wants to talk about B. So are the figures congruent? Are they the same size? Yeah. Our second one is, are they reversed? No, they're not. And then the third one is, if you draw lines connecting, is it going to be perpendicular? No. So let's have you take a look up here. Did they form right angles? They did, right? So the answer to that one is yes. But we see, since we did not say yes to all of them, it is not going to be a reflection. So we say no, doesn't meet properties. Okay. Use the transformation shown, or name the transformation shown in part B. So if it's not a reflection, what is it? It's a slide. What did we call that? Translation. So translation. So we have our first one. It says, which segment is the reflection of AB reflected over the x-axis? So which one is it over the x-axis? JK or KJ, either one of those would have worked. And then if you're looking to see which one corresponds to point A, so if it's over the x-axis, it's going down here. If it's which one corresponds to A, J or K? J does, right? So if you folded it down, it would lie on top of J. And we have J having the coordinates of -4, -1. Which leads you to see that B being reflected over the x-axis would correspond to K. Yep. And K's coordinates are? Nice job, guys. So now we see here that we want to see what happens if it is going to be reflected over the y-axis. So which segment is if it is reflected over the y? Yep, DE or ED, either one works. DE. Remember the line on top because it's a segment. So here A is reflected on top of D, which has the coordinates of 4, 1. And then we have our B, which is reflected onto, which is the coordinates of what? 1, 3. Yep. Do you guys have questions on how we got those?
Yeah, I got a question already.
Our first one up, we want to see, is this going to be a reflection? So if it is a reflection, would it be reflected over the X or the Y? It'd be over the X. So if I folded this directly down, would it lay directly on top of it?
Yes. Oh, yeah.
Yep, so we say yes, this is a reflection. And it's on the X-axis. Our second one up, if this was going to be a reflection, it's going to be X or Y?
X.
X. So is it a reflection? If you fold it directly over, it will be on top of the other one? No. So what do we call this one?
Slide.
Yeah, it's a slide, it's a translation.
Wait, do it matter which one you use when you say?
And this one, it told us to use the gray figure. Oh, so the black one's the original, the gray is the image. So that was in our directions. And then the last one here, if you're looking at this one, what would it be on if it is a reflection, X or Y? Y. And if you folded it directly over Y, does it line up?
Yeah.
Yes. So yes, on Y-axis. So it says determine the lines of symmetry in each figure. So when we talk about lines of symmetry, we talk about where you can fold it and it would lie directly on top of each other, no overlap. So on this piece of paper, if I folded it down, then we'd have this line of symmetry right here, it overlapped completely. If we folded it the other direction, it'd have that line of symmetry right here, it'd fold directly on top of each other. No overlap on not having it, all of it's overlapped. That's how I should say it. So here, if we look at this square, we can draw a line of symmetry straight up and down. We could also have one that goes, I think that one's called hot dog, this one's hamburger. Hot dog or taco, sometimes people say it. What other ones do we have? Do we have any?
Diagonal.
Yep, the diagonals. So directly across. I'm going to have to redo that one. It looks a little sideways. Let's try it here. So that's a little bit better. And then here, our last one. So how many lines did we have?
4.
We have 4, yep. So our N or A answer is going to be 4. Our second one, how many lines of symmetry do we have? We have none. There's no place where you guys could draw a line that would flip over to lie directly on top of the other half. There would always be something that's not overlapping. And let's have you take a second and see if you can figure out how many lines of symmetry are in C. So when we do this, and we start doing lines of symmetry, sometimes it's easier to do it systematically. Well, you see if you bent it directly in half, in the middle, it would create a line of symmetry. So right here, if I folded it just like my sheet of paper, you'd have a line of symmetry. And the same thing would occur if you folded it along this one. So halfway through each side is going to create a line of symmetry. And this one. Are there any other lines of symmetry? Straight through the middle. So through our vertices. And then we can do the 2 diagonals the same way. So through the vertices here and through the vertices here. So where the two sides meet and then directly through the side. So when we go through and we count them, sometimes I find it easier to count starting right here. So 1, and then I go through 2, 3, 4, 5, 6, and then I stop counting because this is my one line still. So we ended up with 6 lines of symmetry. Do you guys have any questions on how we found those? Okay, so a line of symmetry is also a reflection line, true or false? True, right? So if we filled it there, we only had 1/2. We could draw the other one with that 1/2 over the line of symmetry. Okay, and then our last question is about kaleidoscopes. I'm going to pause here, or I'm going to scroll up. So this one says, inside a kaleidoscope, we use 2 mirrors are placed to form a V. And this angle A between the 2 mirrors is related to the number of lines of symmetry in the pattern. By equation, the measure of angle A, so the measure between the 2 mirrors, is 180 degrees divided by the number of lines N. So find the angle between the mirrors of each kaleidoscope. So we're going to start here. We're going to see how many lines of symmetry we have. I label starting at my x-axis, so 1, 2, 3. We have 3. So that means my N has to equal 3. So when we come down here to find our angle measure, we take 180. We divide by 3. I know I didn't give you guys a calculator. Okay, thank you. 60. And so we see that the angles would have to be measured at an angle of 60 degrees between the 2 mirrors. And then our next one is we want to look at the second design. How many lines of symmetry do we have there? We have 4. So we have 4 lines of symmetry, which means my N has to be 4. So 180 divided by 4, 45.